Okay, to do your review, we're going to start with a basic log. A basic log will tell us your graph will look like this. Your domain will be from 0 to infinity. You cannot take the log of a 0 or a negative. Your range in this case is all real numbers. Your natural asymptote is your y-axis, where x is equal to 0. And your point of intersection that we're interested in is where it crosses the x-axis at 1, 0. These are your basic functions for a log of any base. If as the base gets larger, the log graph just gets a little closer to the x-axis. Now, the transformation that we're going to do is to negate the y. If you notice, the negative sign is not by the x, it is by the y. So we're taking your xy and we're negating the y value, which if you run your finger from the positive y to the negative y, it's a reflection over the x-axis. Start this way, reflect this piece, and just bring this up. Now, your new domain stays the same. We didn't change anything. 0 to infinity. Your range stays the same. Negative infinity to infinity. And your transformation is a reflection over the x-axis. Your asymptote is still the same, and your point of intersection is still the same. In the second one, we're again starting with your basic log. ln is the same as log. It's a base e, and e is somewhere between base 2 and base 3. Its characteristics are the same as a regular log. Its domain is the same. Range, or real numbers. Asymptote, x equals 0, and our point of intersection that we're interested in is the 1, 0. For this transformation, we're going to follow order of operations. So the first one we see is a horizontal shift to the right 4. We're going to take the 1, 0. We're going to add 4. We're going to go to 5, 0. We're going to go here. Your second transformation as you go out is a vertical shift up 2. So we're going to take this point, 5, 0, and we're going to bring it up here to 5, 2. And now it's going to go like this. Now, your asymptote, which was x equals 0, is changing only on your horizontal shift. So your new asymptote is x is equal to 4. Your domain, which was 0 to infinity, is also only affected by a vertical shift of 4. So your new domain is from 4 to infinity. Remember, you cannot use 4 because that's where your asymptote is. We did not affect your range, so negative infinity to infinity. We have two transformations, a horizontal shift to the right 4 units and a vertical shift up 4 units, 2 units, sorry. A vertical shift in this case does not affect your range since your range was all real numbers. Our asymptote would still be right here now, where x is equal to 4. In the next 3 equations, 3 statements, there's a minus here, we're going to take these and condense. We're going to use your rules and walk backwards. We want to come out with one term that has a log in front of it. Whatever base this log is what we're going to get. So we can condense these first 2 because they're adding. And when we multiplied like bases, we added their exponents. So we're going to bring this out to an add. We're going to take the add out and do a multiply on this. This is a product one. The next one we're going to look at is the minus. When we subtracted, we were dividing. So we're going to bring out your log base 5 once. We're going to keep your numerator and divide it by your denominator. And we get one expression. In the next one, bring up your power 3. It's got to say 1 log. That 3 becomes an exponent. With the subtract, bring out 1 log and divide. Okay. In the next one, we've got a couple. Let's bring up our exponents first. So we've got log x squared minus log y cubed plus log z. This guy is giving us a multiply. This one is giving us a subtract, which is a divide. So we pull out the log. We set up our divide. X squared over, and this will give us a product in our denominator. Y cubed z. So we've condensed it down to one statement. In this section, we will expand them. First thing we noticed is a multiply, and a multiply in the denominator and a divide all the way through. So let's do the divide. A divide says when we divided like bases, we subtract. So we'll start with a divide and we'll turn that into our subtract. Now be careful because you are subtracting this whole statement. Then we're going to take this, which is a multiply, and we're going to turn that into an add. And you're going to need parentheses here. Now, if you would like, you could leave your parentheses there, or you could distribute your negative sign, which is probably a little bit easier. So if we expanded this one. Now, the last thing we're going to do is bring down this power 2. Okay, in number 7, we see a multiply and we see a power. So let's undo our multiply. When we multiplied like bases, we added the exponent. So we're going to turn this into an add. And then we're going to bring down our power. This next one's going to take a little bit of playing with. We're going to have to put a log on both sides, since it says log r. Then we're going to take this. We're going to convert the root to an exponent. Remember, a square root gives us an exponent of 1/2. A cube root gives us an exponent of 1/3. So we're going to take this apart, and we're going to make this an exponent of 1/3. We're going to use our power rule and bring it down. We then have to separate the numerator, which has a multiply, and then the denominator. So we're going to turn this into a subtract and add your 2 pieces of your numerator. So keep the 1/3 out here. Let's turn the numerator in. And then do minus log c. That's for your denominator. Bring down this 2. So you end up with 1/3, 2 log a plus log b, and you no longer need the extra parentheses, minus log c.